Can we capture the summer sun to power the depths of winter? Europe leads in renewable energy, yet storing it for weeks or months remains costly, risky, and inefficient. 4 years ago, Reveal set out to change that with a bold idea of storing energy in aluminium. So, we asked a simple but transformative question. Could aluminium be the missing link in the transition to clean, secure, and flexible energy? As we work to find the answer, let's take a moment to hear from our project coordinator, IceTech.
For the development of Reveal aluminum energy storage cycle, IceTech and Artus have been advancing a carbon-free aluminum smelting process. The technology has now been successfully validated at laboratory scale here behind me, demonstrating high energy efficiency and significant environmental benefits compared to conventional aluminum production.
This carbon-free aluminium, produced in Iceland, represents a truly sustainable metal fuel, or more precisely, a metal energy carrier. But since aluminium isn't yet used this way commercially, the concept first had to be developed from the ground up.
Hello, my name is Michael Haller. I lead a research group at the Eastern Switzerland University of Applied Sciences, OST. As a partner in this project, we had several tasks. First, we were responsible for the overall concept. That means we analyzed mass flows, energy balances, and the environmental footprint of the entire energy storage cycle. Second, a team of SPF Umtech investigated low-temperature aluminum-water reactions. And third, a team of OST SPF developed and built a prototype that converts aluminum with 2 kW of heat and 2 kW of power in the form of hydrogen.
Researchers from the National Institute of Chemistry in Slovenia developed a complete setup to study how aluminium reacts with superheated steam. Their experiments revealed that high temperatures and pressures lead to fast reactions, generating hydrogen and heat, despite the fact that we are using larger, fire, and explosion-safe granules. This confirms the Reveal Alu-to-Energy concept as a promising solution to utilize and distribute renewable energy.
The result of this development is the machine you can see here in our lab. It has been tested in the past months, and we have confirmed that it is possible to continuously produce hydrogen and heat from aluminum in an automated way. We also verified that such aluminum grains, as you can see here, have a storage density of 15 megawatt-hours per meter cube on a bulk volume base. That means that if you want to provide the same amount of energy as a certain quantity of mineral oils, for example, the quantity you see here, we actually need 1/3 less volume. So this aluminum replaces this amount of mineral oils. And we have been able to show that the reaction of aluminum is both fast and complete. This is important for a good control and safety of the process and for a high efficiency of the aluminum to energy conversion. The results are very promising. There is a huge potential for filling winter gaps of energy supply based on aluminum as a renewable energy storage vector. Therefore, we decided to launch a startup company, Apricot 366. This company will commercialize the technology in the coming years.
My name is Samuel Sinanu. I work as a senior research scientist with SINTEF in Norway. And what I'm doing in the Reveal project is to help with the electrolysis process for the production of green aluminium using the inert electrode configuration. And they're also part of the work package that looks at the recycling of aluminum hydroxide back into aluminum oxide that can then be used again to produce aluminum metal. So we do this kind of characterization tests to make sure that we have the right quality of aluminum oxide that can be used in the electrolysis process.
This circular approach makes Reveal's solution truly remarkable. The next step? Scaling up towards commercialization and assessing its full life cycle to understand the environmental impact and improve how it's made.
To conclude that, we also added a circular economy assessment where we looked into waste, input materials, lifespan, and other aspects to see how circular is the system.
And the results are astounding. By using low-carbon electricity sources, such as PV, wind, or hydro, the Reveal aluminium storage cycle reduces the carbon footprint by 60 to 80% compared to a conventional mini CHP systems running on natural gas.
Now we come to an end of this project, but it is just the beginning of a longer journey that may revolutionize the way we store and transport renewable energies.
Thanks to European and Swiss support, partners from 7 European countries formed a Reveal consortium and turned a bold idea into working technology. Aluminium isn't just a metal, it's an energy carrier for a climate-neutral future.